All right, so I'm going to talk about how I like to architect an LLM-powered web app. So my example is in Next.js, but these concepts will really apply to any stack. So first we'll look at LLM orchestration, which means how to coordinate your AI calls in the workflow of your app. Then we'll look at how to separate the responsibilities of AI calls. So instead of having one big LLM call that returns a lot of data, we can split them up into multiple calls that each do one thing. Then we'll look at layers of abstraction within the AI calls to make your code easier to maintain. And probably the most useful is making sure the AI adheres to return types without needing to change the prompt. All right, so this is our example website. It creates a D&D character. So it first makes an LLM call to create the character idea, and then subsequent calls to create an image and the starting inventory from that character idea. So I'll explain why I separated those when we get into the code. All right, here we are in our Next.js application. So this page.tsx has the React code for the character creator page, and it's just some simple HTML to display the generated character. And when our button gets clicked, it calls create character up here, which in turn calls generate character. Generate character lives in our actions.ts, and in Next.js, everything in actions gets run on the server. So this is where we're going to make all of our AI calls. So our generate character function does nothing but call other functions and puts the return values together into a complete character object. So first we will just get a random D&D race and class. No AI here, it's just choosing the random ones. That in turn is going to get fed into the character idea, which is, it's gonna call an LLM to generate the name, gender, personality, etc. And next we'll generate the starting inventory and the image for our character. So I know it's simple, but this is actually our orchestration layer. This function's sole job is to do nothing but call other functions. And so here we can kind of be efficient with how we call things, and we can call things in parallel. So we've got 3 AI calls here: generate character idea, generating the inventory, and the image. So we have 3 AI calls here, generating the idea, the inventory, and the image. And because the second 2 rely on the first one, we can run these in parallel after the first one has already finished. So in my opinion, you should do the orchestration by hand like this in most cases until your app gets pretty complex. If you've heard of LangChain, it's a framework for orchestrating AI calls, but I actually don't recommend using it in most cases. It's just too complicated and rigid. You end up having less control over your AI calls because there are a lot of hidden prompts under the hood that are a big pain to change. So in my opinion, it's better to start simple and only add in abstractions as your app grows more and more complex. So we'll get into these AI calls in a second, but I wanted to touch on why I separated them from each other. It's probably obvious that the image is separate because it's not text, so that's a different AI model. But generating the inventory is just, a list of items. Someone might say that generating the character idea and the starting inventory could happen in one LLM call. And my answer is that it's actually a good rule of thumb to separate responsibilities. And by separating the inventory creation, we gain a few things. So first, it's easier to test in isolation because it's completely separated. And you have more control over the output because it's easier to tweak the prompt that's just about the inventory rather than having it be a part of a prompt that tells the AI to do other things too. So in general, it's best to have your LLM calls do as few things as possible. All right, now that we've gone over the orchestration and separation, let's dive into the individual AI calls. So first we generate the character idea. And here we're really just making a simple call to generate structured data, which is an abstraction from making the AI call. Because this is abstracted, as in we're not making the AI call directly in this function, it's a lot easier to change the way that we make the call and which model to use. So all we need to do in here is just define our system message, which tells the AI that its job is to create an RPG character idea given the racing class. We'll construct the prompt with those randomized racing class, and we need to pass in the schema for the object we want returned. So let's go into the schema. This is super helpful when generating data that needs to adhere to a specific type. We're using this library called Zod to define the structure of the JSON object that we want the LLM to return. So we're saying we want a name that's a string, gender that's a union of string literals, so it's got to be male or female or other. And we can also put in strict rules about the properties. So for example, personality is a string array, and we can say that it's got to be a minimum of 3 length and a maximum of 3 length. The LLM will see this and almost always follow the rules that you set. It also means that if the AI returns a list that does not have a length of 3, which is pretty rare, even in the more simple models, like I've been using 4.0 Mini, GPT 4.0 Mini, which is the cheapest and fastest model, and I've pretty much never seen it break any of these Zod rules. But if it does, it'll actually throw an error, which is pretty helpful to make sure the AI carries out specifics in the data that it generates. Next, we use Zod's describe. So the AI sees these descriptions and will follow their instructions. There's also an added benefit that they also act as inline documentation. And because we can use these descriptions here, we don't have to make this large prompt that lists out every property in the return object. All we have to do is code it directly into the schema. So for example, I'm describing the backstory as it should be 1 to 2 sentences. It's way nicer to have it in the code here than in the prompt. And so we'll define the rest of these properties. And at the end here, we export a type that's inferred from the Zod schema, so we can use it as a TypeScript type in our code. So see, it creates this character idea type that we then use as the return type here. Now let's go to where we actually make the LLM call in generate structured data. So this is a function that I will reuse every time I want to make an AI call that returns an object. And here we're using the AI SDK's generate object that takes in the model, the Zod schema, system message, prompt, temperature. And all this is a wrapper around the AI SDK. And one of the benefits of having this in its own function and not calling generate object directly is that if we decide that we don't want to use the AI SDK anymore, we could swap it for another library with pretty minimal changes. So let's go back to the orchestration layer. And we will take a look at generate starting inventory. This one is simple. It follows the exact same pattern as generating the idea. It just has a message, a prompt that it creates in here, and it calls generate structured data. It also passes in its schema. So it's defining an inventory as just this list of items. And finally, we generate the image. So here we're constructing the prompt and we're putting together the physical description of our character. And we're using a similar abstraction pattern with generating an image by calling a function whose sole job is to call the model to generate the image. So we'll go into that. Here I'm using Replicate's AI model hosting to call Flux. And Flux is an open source image generation model that's quite good and very cheap. A lot cheaper than OpenAI's DALL-E 3. I'm using Flux Schnell. Schnell only costs 3 cents per image, takes about 0.6 seconds to create an image. This is Flux's fastest and cheapest model. Schnell actually means fast in German. And their best performing model, Pro, looks way better, but I actually recommend Flux Schnell for prototyping because of its speed and cost. Again, because calling the image model is in its own function, it's so much easier to change this to use a different model within Replicate or to not use Replicate altogether. All right, well, that's it. That's my example of a simple LLM-based web application and how you can architect it. The link to the GitHub will be in the description, and have a great day.